Good morning. I hope those of you that I haven't met before didn't read the agenda and think you were actually going to see a model up here. It's sorry, just me. The model we're talking about here is the Chesapeake Bay watershed model primarily. It's a very complex mathematical simulation of the watershed of the Chesapeake Bay, 64,000 square miles of it. And it's important to us, particularly in the urban and suburban environment, mainly because that's one of the source sectors, one of the areas where we expect to see growth in the future. Future development means you get more urban and suburban areas. In order to address the water quality in these urban suburban areas, we need to rely on the Chesapeake Bay watershed model to guide us toward meeting the Bay TMDL. Specifically, we're talking about the latest version of the Chesapeake Bay watershed model. It's version 5.3.2. That's the version of the model we'll be using through 2017, at which point we expect it to transition to a new version of the model, phase 6 maybe, version 6, that we'll use from the 2017 period to sometime in 2025, when we expect to have all of the practices necessary to meet water quality standards for the Chesapeake Bay in place. The Bay model is the established tool. It is the stick by which we will all be measured for evaluating implementation plans, like the state's watershed implementation plans that we've developed, 2-year milestones, as well as for evaluating progress. That means as we track all of these trees or best management practices that go into place, we need to make sure we can capture that information in sufficient detail that it can be reported into the model, producing credit or reductions as we progress toward meeting the lower loads associated with the TMDL. The model defines which BMPs are acceptable for credit and quantifies the credit that they produce. It's been described as a state-of-the-art model, world-renowned model, one of a kind, all very likely true. But what we need to understand is that it also has limitations. Scale. You can't use one model to answer every question. This model, because of the way it's designed and developed and calibrated, it's designed for use at the Bay-wide scale. We want to make sure that the loads coming off of the land as they reach the Chesapeake Bay watershed and start impacting water quality there, we want to make sure those loads are as accurately represented as possible. That's how we calibrate these models. There's also issues of source specificity. So the model itself is calibrated to water quality monitoring in streams at multiple locations, probably about as many sampling stations scattered around the 64,000 mile watershed as we have people in this room. So several hundred monitoring stations that are used to calibrate the model. But that calibration isn't necessarily equal at every point. The calibration for the monitoring station back in that corner may have a little more variability than the calibration station down here at closer to the fall line where it reaches tidal waters. All of those are important, but they affect the scale, they affect the specificity of the sources. We don't know from the monitoring data where that nitrogen comes from in most cases. Maybe there's some point sources where we actually have measured nitrogen discharges, but for the most part, we know the total amount of nitrogen, and we rely on the model and all the assumptions that underlie that model to distribute that load back across the watershed. So through this calibration process, we try to make the model as accurate as we can, but again, we have to remember that there are limitations. It's a tool that, like any other tool, if used properly and for the right job, can inform our decisions and guide our actions. To try and improve the accessibility of the model, the state, with help from EPA, has developed the Virginia Assessment and Scenario Tool. This is a web-based application. Anybody can get a login for it, and it lets you apply different implementation scenarios, collections of BMPs on the landscape, and see what the model would be expected to produce in terms of loads. So if you have a project that you're considering, you can use the VAST tool to try and get some sense for what the reductions that might be generated from that project are. Again, the VAST is aligned currently with the watershed model, so depending on where your project is, the accuracy or true impact that that project will have could vary by some margin of error that is frankly undefined for the watershed model. But we're hoping to make some improvements to the VAST tool that will make it even more useful to local governments as well as nonprofit organizations or collaborations like this one. Recent plans for enhancements to the VAST include adding the ability to define your own land use. Right now, the tool uses the land use that's defined in the watershed model, which through our WIP2 planning process we found often was not accurate when you got down to a local scale. Again, a function of the assumptions that are made in a large-scale model. But when we make this enhancement in VAST, you can define the specific land uses that you want to treat in a specific area, better refining the loads that you might expect to reduce as a result of your project. One of the other improvements we hope to make to VAST is adding a cost component. Allows you to develop an implementation scenario with an understanding of the costs that might be associated with it, something that we haven't had to date. I think with these enhancements, the VAST will become very useful for you in this process as you think about your implementation projects. But again, it's a tool, one of many tools. It should not be used solely as the only decision-making support tool. Never abandon common sense. If the model's producing results that you find unbelievable, chances are they're wrong. Don't put blind faith in it. Use the VAST, but also use your previous implementation experience. We have lots of experience, we have lots of efforts on the ground, lots of scientific literature that support it. Use those as well to inform your decision making. Collaborate with those experts, but use the tool as a tool to guide you in those decisions with an understanding of its limitations.